last, we will discuss an exercise on the production mix. We have this situation. We have our company that realizes 3 different types of beer. We have beer type A, beer type B, and beer type C. We have some data that we know about our production. These are the information that we know. We know the price, the unitary price, the variable cost, the weekly demand in terms of units, and then the machine time. So this last line that is really important represents how many minutes we need in order to realize 1 unit of each of our products. In addition, we have, let's say, a problem, and this problem is that we use just 1 machine in order to realize all of the 3 products. The problem is that the machine time has a limit. Let's say that we can use our machine for a maximum number of minutes during the week that we are analyzing of 9,300. So basically we have 9,300 minutes available for the production of this week. But if we look at the quantity and at the time that you need in order to realize the quantity, you can see that you don't have enough machine time to satisfy the weekly demand. So the question is, what is the order of production? And then moreover, how many units of each of our beer should be realized in order to maximize the profit? These are the 2 main questions. And we can address this problem by addressing the production mix, let's say, by addressing the knowledge that we have about the production mix. So basically, the starting point, as whatever kind of short-term decision, is the calculation of the contribution margin. So basically what we can do is to calculate the unitary contribution margin per each of the 3 products. We can start from the product A. The contribution margin is the difference between the unitary price and the variable cost. So we will have that the contribution margin for beer type A is 1.8 euros per unit. Then we can do the same for the beer type B, so the price minus the variable cost, and we have that the contribution margin is 1.2 euros per unit. Then if we move to beer type C, we can calculate again the contribution margin of 1.4 euros per unit. This calculation is important because we know which is, let's say, the most profitable beer. And if we look at the contribution margin, we can see that beer type A is the most profitable, followed by beer type C and then beer type B. So if we do not have any constraint, this would be the optimal solution. Beer type A, then beer type C, and then beer type B. The problem is represented by our constraint of the machine time, so we do not need to reason in terms of contribution margin per unit, but we need to calculate what is defined as contribution margin per scarce resource. So the contribution margin per scarce resource is just the contribution margin divided by the scarce resource, that in this case is the time. So our time is the scarce resource. So basically we can calculate again the contribution margin, but in this case is the contribution margin related to 1 unit of production of our machine. So basically we need to divide this contribution margin by the time. So if we divide 1.8 by 4 minutes to realize 1 unit, we obtain 0.45 euros per minute. This means that every minute that we are using the machine to produce beer type A provides a contribution margin of 0.45. If we do the same for the other 2 beers, we will have a contribution margin of 0.40 for beer type B, calculated again as the ratio between the unitary contribution margin and the time. And then finally, we will have a contribution margin per scarce resource of 0.56 for what concerns beer type C. Then this kind of result is particularly useful because it provides us with information about the order of production in the presence of this scarce resource, that is the machine time. So basically, the order of production should follow, let's say, the product with the highest contribution margin per scarce resource and then the others. So by looking at this data, we can say that the first product that should be produced is the beer type C. So that's the first one that should be produced. And the reason why, it is because it has the highest contribution margin per scarce resource, which means that if we use our machine for 1 minute of the production in order to realize the product C, the machine is able to produce a contribution margin of 0.56 euros every unit that is realized of beer C on the machine. And then the second one should be the beer type A, and then the third one is the beer type B. So with the contribution margin per scarce resource, we have identified the order of production. The second question is how many units should we produce? Now we know the order, but still we need to understand how many units of each product we should realize. The starting point is the beer type C. So we need to identify the number of units. What should we do? Basically, we need to identify the units that we should realize, so 3,000 units. That is this value, our weekly demand, multiply by the production time. How many minutes do we need in order to realize our production? And the quantity is the following, 2.5 minutes per unit. In order to realize the overall production of beer type C, we are employing our machine for 7,500 minutes. Okay? Now, if you remember, we have an overall machine time of 9,300, so we need to identify the time left. The time left can be calculated as the difference between 9,300 minutes, that are the overall number of minutes available, minus 7,500 minutes that we are using the machine in order to realize the product C. So we can see that we have 1,800 minutes left in order to realize the other production. Given this time that is available, which is the other product that we can realize? And it is the beer type A. So basically, let's concentrate now on beer type A. The problem is that we have just 1,800 minutes left, while we need much more time if we multiply the weekly demand by the time that we need for realize one unit. So in order to identify how many units we can produce with the available time, we just can divide these 1,800 minutes left by the time that we need to realize one unit of our beer type A, which is 4. So that we can find that we can realize 450 units with the time for which our machine is available for the remaining part of the week. Let's try to sum up everything. Basically, when we have these kind of problems in which we have a scarce resource that does not give the possibility of realizing the entire production that should be realized, like in this case in which we have the constraint of the machine time, we can apply the approach of the production mix. With the approach of the production mix, rather than calculating the contribution margin, our reference point becomes the contribution margin per scarce resource that provides information in terms of the, again, the unitary contribution of our production with respect to the scarce resource. We look at the product with the highest contribution margin per scarce resource in order to identify the order. And then, once we have identified the order of production, we can identify the quantity of each product that should be realized by, let's say, consuming the scarce resource. In this case, it was the machine time, the scarce resource, so we have first of all produced the entire product beer type C, and then we have moved with the remaining time to the beer type A. So basically, given the three different products, the mix that maximizes the net operating income is the mix that is constituted by 3,000 units of beer type C and 450 units of beer type A. Pay attention, because in real life we're not producing beer type B, but in real life this could be a problem because it depends if the market is requiring our beer type B. So in real life we should also think of the possibility of producing also beer type B, even having a lower net operating income, because we need to satisfy also the market demand, because in this case we are not producing at all beer type B.